Hi everyone. So today I need to discuss about abstraction, which is a very fundamental object-oriented concept. So if you're doing a computer science or software engineering degree, you might have definitely come across this concept. So the reason why I thought I need to discuss abstraction is it is a bit confusing topic for me when I was in my first years. So and the other one that the other reason is when I come across with real world examples and design pattern, it's a bit different from what I understand as abstraction and how they actually used it. So as you can see, I have kept my definition of abstraction slide empty because I think it kind of gives me a false alarm that I have understand it. This is it. But when it comes to the real world, there's a gap. So because of that, I thought we'll keep this slide empty for a while and we discuss the real world example. Then we come back to the definition of it and discuss a code based example. So I want you to imagine a situation where we drive our cars by sitting inside the engine room. We don't have a steering wheel or gas pedals. We just drive our vehicles by sitting inside the engine room by controlling levers, by controlling valves and all those things. So suppose that you buy this type of a car and you drove for 15 years. So then you came up with a problem in the engine and you go for a garage and they told you to replace the engine. Yeah, so you say fine, replace the engine, and you get back to the engine room. Now you are seeing a different engine. You don't know which lever to pull, how to add oil. You don't know anything. Because of that, first let me tell you why this is happening. Because you heavily depend on previous engine's implementation. So suppose a situation, in the real world, we have a steering wheel and a gas pedal. So you don't depend on the complexity of the engine. Instead of you depend on a simple interface, a steering wheel and a gas pedal. When the engine is you don't know about how the internals work. You just depend on steering wheel and gas pedal. So the manufacturers can change engine or change the way they have done it. It doesn't matter to you because you are provided with a steering wheel and a gas pedal. So this is the concept of abstraction. So let's abstract as the slide say, abstract the complexity of the engine internal functions by introducing a simple interface like a steering wheel and a gas pedal. So the driver is always happy. Why? Because he depends on the interface, not the actual implementation. So that is the concept of abstraction. So if we come to the definition of it, abstraction says abstraction in OOP is a core principle that simplifies complex systems by hiding unnecessary implementation details, showing only essential features and functionalities to the user. This is the textbook definition of abstraction. So I need to discuss this abstraction concept further with a design pattern known dependency injection. So every design pattern, every programming concept, every software engineering concept is there to solve a particular problem. So without going directly into the dependency injection, we will discuss why dependency injection is needed. Now let's suppose that we have two services. One is my service and it depends on my logger. So my services uses my logger to log something, maybe console log or whatever. To log something, my service is using a my logger service. So as you can see in the left side code, we have created the my logger object inside the my service. Now so I need to highlight one another thing here. This violates single responsibility model because my service have two responsibilities. One is from its own class and to initiate the mylogger object inside of it. This is a problem. So let's look at why this is a problem. So let's suppose that in the first part mylogger object doesn't expect anything in the constructor. But suppose if my logger changed to constructor to accept my file write object. So it changed to accept another object as the constructor. So my service also should be changed like that. We can't construct it because it is expecting something my logger class. So we need to provide that also. So that change happened in the my logger object. I mean that change happened in the dependency affect the my service class also. Because of that, this is a problem. So dependency injection came because of this. So in the dependency injection, we don't directly create our dependency in our class. Instead of it, what we do is we create it in another place, and we inject that service into we inject that dependency into our service. So in framework, this was handled by the frameworks, like in the Nest.js, when it comes to Nest.js, we can mark our services as injectable to tell that this is a dependency. So Nest.js will resolve and inject the dependency during runtime. Yes. So the next thing is the dependency inversion principle. This is saying the code should be depends on abstractions as opposed to concrete implementations. So what is that means? So as I have told earlier, my services depends on what? My logger class. Now suppose a situation where I have so many logger classes. Let's say in order to write logs of DB, I have a DB logger class. In order to write cloud related logs, I have cloud logger class. Let's suppose my service is depend on DB logger. So when I pass a cloud logger to that, it can't work because it's only expecting a DB logger. So why is that? My service is depend on my cloud logger or DB logger implementation. So dependency inversion principle suggests that instead of depending on the implementation, you should depend on interface. That means abstraction. So interface gives you a contract. Like if you are implementing meme, you need to implement these functions. It doesn't know how. It doesn't mention about how to implement, but it should say you have to implement this. So because of that, now think iLogger interface. My services depends on iLogger interface. It just only expects a iLogger interface. So when there are three classes as MyLogger, CloudLogger or DBLogger, and they have implemented the iLogger interface, these all three can be passed to the my service depending on the need. Maybe in the dev environment a different logger, maybe in the cloud environment a different logger. You can pass any of these dependencies. You can switch dependencies because of this. So as the slide says, any logger that implements iLogger such as MyLogger, CloudLogger or DBLogger can be injected to my service, making dependencies easy to swap for testing and configuration purposes. Yeah. That is the dependency inversion principle. So now let's see with the code. So in here, first code block is the interface, and I think I have curly brackets in there. It's a bit wrong, but we should have only the method signature. So in the first code block, there's a iLogger. That is the interface. So the other two, they are implementing the iLogger interface. So as the interface say, they need to implement log method. So both of the cloud logger and the DB logger implement this interface. They have implemented it. So my service class not depend on the implementation. It just expects a iLogger object. So it doesn't depend on the implementation. It depends on the interface. Because of that, we can pass the DB logger. When we pass the DB logger, it log the it prints log to DB. My service is running. Now we can pass the cloud logger. It doesn't matter because it depends on the interface, not the implementation. So interface is the iLogger, implementation is the DB logger and the cloud logger. When you pass the cloud logger, it just print log to cloud, my service is running. So this is the concept of abstraction and how we used in practical design patterns and things, and I thought you might understand of it, and thank you very much for joining with me.